Yeah, football Champions League.
So, good afternoon. Am I on? Yeah, I am on. Okay, so good afternoon. Welcome to, I don't know how many of the annuals, we've been here since 1995. So you guys are better at math than I am. It's a long time. I've been doing this for 20 years. And this year, some things have changed. The Hydrogen Fuel Cells Europe, our new identity. And also, we haven't seen each other for 2 years, and in that time, things have been developing in the background. I'm going to be talking to Georg Dura, who is from TriHi, and he'll be explaining what that is. And we'll be talking about the Innovation Technology Center hidden behind the Abkürzung ITZ. So it's the Innovation Technology Center in Duisburg. Welcome, Georg.
Thank you very much, Brian, for the introduction. My name is Georg Dura, and I'm for the TriHi. It's a proving ground for hydrogen heavy-duty application. This should be a proving ground in an industrial area with a hydrogen facility to test the whole equipment for heavy-duty vehicles.
So when you say heavy duty, I'm interested, first of all, in where it's located specifically. Locations have side benefits, or they don't. So what is specific about your location and its size, and what features does that location provide you with?
The size is very special. It's 80,000 square meters. It's a big hole. It's in an industrial area. It's a steel factory. And so we have all the regulations we needed for handle the hydrogen. And it's also a restricted area. You can come on the area 24 hours, 7 days a week. So there's a shift working there. And it's located near 50 minutes by car to the airport of Düsseldorf. And it's near to the Rhine. And there's a lock port in Duisburg. It's nearby for this hole. So we will make tests in this big hole, and you can rent it. That's special for this application. And we will test their very big systems, so that we need a lot of hydrogen. And very special is that we have a hydrogen pipeline near to this hole, so that we can do a lot of tests parallel, and also for a long time.
I find it fascinating. You call it a hole, but there is a wonderful architectural idea behind this, with this house in the house concept. That's a Scandinavian thing, isn't it? It's kind of...
Yes, that's what I saw in the Netherlands. The hole is from 1911, so it's a very old hole, but it's beautiful architecture, and we will combine it with a new technology. And this was the spirit. It was my idea to combine it to bring the new step into a steel factory, because they have also to do the step of the decarbonizing. And so they will, in 6 years, they will operate with hydrogen also in the steel factory. And we now do the first step. And the idea is to bring the containers into the old ambient. And it's a closed system, and we can bring test containers in it, where we have the proving ground, and we can put very large systems which are powered for vessels or LKWs. And they need a lot of hydrogen, and we test in this container system the system, and it is in-house. And the idea is that we are ready now. We have a hole, and we only bring in new container, and we only need the time to build the container with the testing equipment. So I think in 1.5 years we can be ready to help the industrial companies to go on the market, and really to test if the system has all the things he need.
So I get the advantages. You have a supply of hydrogen there. It's an industrial environment. You can operate 24/7. Something in common with heavy metal musicians and heavy metal. They make a lot of noise. There you can practice around the clock. But whenever we in this industry hear testing, I have to admit there's a sigh that generally goes through the audience, because back in 2004, it seems like that's what we were doing all the time. And now we have commercially viable products like forklift trucks. They actually beat other competitors in the industry in logistics if you have to operate indoors. Many people think that we're beyond the testing phase. Come on, we're not R&D engineers that show up with laptops and one fuel cell, and there's 14 engineers operating one fuel cell, and they get it operating on stage for us and people applaud. Why do we need testing now? Aren't we through that phase?
Yeah, Brian, we need testing because, we are not on everything. We have not the capacity on the market now, and it is very expensive to build up this testing equipment. So we at the beginning, we have some examples. The forklifters, for example, and but we have not reached standards. So this is another goal we try to reach, is to create standards, and so it's necessary to test a lot of things, or a lot of fuel cells and systems, and also to make it more commercial, to make it cheaper. So this is the idea. This is at the moment we have, I would say, it's 1, 2, but what we want to reach is to build 300, 500, thousands. And so we need a test capacity, and also at the moment we have not so much institutions who are able to giving a proving mark. So it have to prove, and to say if you buy a 100 kilowatt system, is it really 100 kilowatt? Can I get it out of the fuel cell? And is the whole system in all the specs? So you need a certification or something else. A lawyer who can say, okay, that's right.
This is the hidden dimension. When I look back again in the early 2000s, here we are, a fuel cell industry telling people about the cars we're going to build and the applications and so on. We had demonstrated devices. They were not allowed to bring in a direct methanol fuel cell simply because there was no objective certification process that it was safe. And if it's not certified, the guys at the door are going to say, go home. The same thing happened to us with the fuel cell running on hydrogen, the hydrogen tanks. Are they certified for indoor public events? Who's got the certification? How do you prove at the door that you can actually enter the building? So I say the word door as a metaphor for gateway. The larger the application, the more one has to think about the certification process.
Yes.
And for me, this is interesting because your certification testing facility is all about size. So what specifically are we talking about? Thankfully now there's already certifications for small vehicles and things like that. But the larger you get, the more we've got this interesting chain of things that needs to be certified: the tanks, the fueling stations, the vehicles themselves. So, let's start with the largest things that you actually deal with at your facility.
At the moment we are dealing with. I think you have a problem.
Is the microphone on?
The microphone is off. Oh, sorry. So, okay. So the biggest things we are dealing with is with vessels. So we are in a big project. It's called Rhine, where we try to bring 5 vessels in the next 5 years on the Rhine, powered by hydrogen. And it's done by a swappable container, because you can imagine that the container system on a vessel, they have not time to tank or something else. So we choose a swappable container, and at the moment we favorited a 20 feet container with 500 bar, and there are 500 kilograms of hydrogen on it. And so to give you imagine is that we need 20 tons for a journey from a vessel from Rotterdam to Duisburg and back. So and we are we create a system. You can imagine that you need another fuel to drive up the Rhine or down the Rhine. So it's a very complicated system, and we need storage in this container, in these 20 feet containers, and yeah, we have to prove if we can fill it and so on. This is what we handle, and also for the big LKWs, we need new filling protocols. So at the moment we have only filling protocols for cars, and the car needs, for example, 4 kilograms of hydrogen. But if we talk about LKWs or trucks, yeah, we need 40 kilograms of hydrogen, and so we have to, yeah, the flow rate has to be higher, and so we have a lot of technical, tricky systems, and so this is another point where we yeah, handle a very large scale of hydrogen.
It's interesting for me because we've actually reversed the approach. Cars, let's face it, cars are sexy, right? So everyone looks at the fuel cell cars and they think, I want one. But in fact, a viable mass-produced car needs an infrastructure. The infrastructure cannot develop if you only have a few hydrogen fuel cell cars, whereas you can build up chains of buses, chains of ships. And for me, it's interesting, we were talking about this during the prep. In fact, where legislation is becoming the mandate for using hydrogen in ships is when you think about the ports in Italy with the diesel-powered, super polluting ships. The locations in Scandinavia where they don't want the destructive influence of hydrocarbons being burned as they drive up the fjords and all of that. So is that partially what is, like, to develop a test facility is largely a recognition that there's a future market and that the market needs certification now in order to move at speed forward. Is this part of the dynamic behind developing this facility, the recognition that this is going to happen?
Yes, this is the reason, because we will give a hand to make it quicker. So because I had a lot of talks with the Netherlands, where they are very big in shipping, and they build a new pipeline from Rotterdam to Venlo, and they will have 2025 they will have the hydrogen in pipelines. So they make big steps on the decarbonization. They will make the whole shipping in Amsterdam with hydrogen, so carbon free. So they had a lot of pressure, and yeah, the whole logistic is under pressure because every company asks for to reduce the CO footprint, or the CO2 footprint, and this is the only way at the moment we can do. We have no other way, and so yeah, this is the reason why the Ministry of Traffic said, okay, we need institutions who can give a help to bring things in the market. We are now ready. We have done a lot of science in this area. We know that a vessel swim on a river. So what we have to swim now with hydrogen, and we have to try it. And yeah, I'm also on regulation for shippings, so that we change the rules. So the regulation needs a lot of time, but we try to speed up it, so that we at the moment with a group of radars, we try to build a powering system for hydrogen, a propulsion system, so that we can get a certification for this system, so that not each ship needs a single regulation, so that we have a regulation for this block, and so everybody can use it. So this is the first step for a serious production.
You mentioned two things earlier on. One, of course, is the shipping application, the lack of standardization and certification standards, which are so important. Europe has its advantages. People complain about the bureaucracy, but boy, the idea that there is such a large chunk of the map that has certification processes that are European-wide, it is a huge strategic influence on international applications as well. There's spin-off effects. I find that interesting. But one of the things that you mentioned in addition to shipping begins in this European context. It could be tourist boats, but at some point maybe it's international. The trucking thing, the trucking proposition for me is fascinating. What is the different... you already mentioned the size of the tanks on the ships, 20 feet long, 500 bar. And there, the interesting difficulty is the speed of refueling.
Yes.
And therefore, the swappable tanks, which I find so interesting. I've never heard this concept before. By the way, this is the first time I've encountered it here in my 20 years. Rather than slowly refueling in order to do away with some of the issues of changes of temperature and so on, you swap the tanks and refuel at your leisure to some extent. What are the different dynamics in the truck tank proposition?
Yeah, you need you need a higher flow rate. So you will not tank 20 minutes or 30 minutes or 40 minutes. So you bring in the tank the hydrogen. And the problem is that the tank should not get heater than 90 degrees. So you measure every time the temperature into the tank, and then you couple it out to the filling station and say, okay, have to cool or to heat the hydrogen inside, so that the temperature is below a critical temperature. And you have to handle that there is no frothing on the pipeline and so on. It's very complicated. It's to reach a maximum of flow rate, to control the physics on the nozzle, so that you can fill in a very short time your truck tank, where you tank 40 kilos of hydrogen in gas. So in the beginning of you can imagine in the beginning of a tank process, the tank is nearly empty. So and in the end it is 350 bar. So it's a dynamic process. So it's hydrogen is a very special gas.
Yeah.
So and you have to control the physics inside the tank. So it's totally different to a benzene tanking system. So this makes it very complicated. And also the cooling is very, very expensive on the filling station. So you try to get a very, very slow dose of cooling and so on. And this is very tricky.
I've rarely had a conversation where the details of refueling have been discussed in such detail. One of the selling points, of course, of hydrogen, when you talk to people who operate hydrogen cars, is an electric vehicle needs to be charged over hours.
Yes.
And then they will say, but I can tank up my car in 2 to 3 minutes. And in fact, one of the advantages of the forklift trucks is rather than having 3 sets of batteries or 3 forklift trucks, you have one, and the refueling time there is a matter of minutes. I have to ask this question. Are they telling us also the bad side of this refueling proposition? The question behind this is, I think there's limitations to the battery model for ships, and it's simply because of energy density. and the fact that batteries decline over time and don't like to be discharged entirely, don't like to be overcharged. There's all sorts of things that one has to be aware of. And people, for that reason, say if you want to build a truck, the electric trucks don't have the same business model proposition as hydrogen trucks. Is this true despite the fact that there's refueling issues that we need to address?
Yeah, the big problem on the battery is the winter time.
Okay.
So yeah, you cannot believe it, but I drive a hybrid, and I was surprised in the warm time. I can reach a very large distance, and in the winter time. So how will you handle it on ships, for example? I think the battery system is a system for the city. And for middle distance and long distance, we can only use a hydrogen system. And for example, I discussed it with a customer who said, okay, what we need refilling systems rolled on the road, so mobile filling system. But in hydrogen, it is possible. If the truck reach not the harbor, you can bring a mobile system to the truck and refill 10 kilos, and he can go on. But what is when a battery truck lies on the street? Do you have a cable or something else? You need a big one, and you cannot change the battery.
And there's people here who tell us we're going to run out of copper if we
Okay.
try. So, okay. George, it's been a pleasure talking to you. The booth is over there, I
Yeah.
believe. And for further questions, you should visit him. I've been talking to Georg Dura, who is from Tri-High, about the Innovation Technology Center in Duisburg. It's been an exciting talk. I hope to see you back here next year.
I hope so too, Brian.
Okay. Thank you very much.